Hello, everybody. Today we will be going over the unit circle and radians. So last class we were introduced to the unit circle and its special families, the 30-degree, 45-degree, 60-degree, and reference angle families, and their particular set of coordinates. Today we'll be going over radians. It's just another way of saying, if I were to say, hey, where is pi over 6, and what would that be in degrees? Pi over 6 is here, that would be 30 degrees. If I were to say, hey, where is pi, and what is that in degrees? Well, from the positive x-axis, if we were to rotate over to pi, that would be 180 degrees. So it's just another way of calculating things as it comes to math. If you would please pause the video, fill in this chart. That way you will know all of the radians that we're going to mainly cover in this particular class. Okay, for the second page, we are going to graph terminal rays, much like we did in day 1 and day 2 of this unit, except now rather than them saying, hey, plot the terminal ray of 45 degrees, now it's pi over 4. Well, we can use our little unit circle here to determine where pi over 4 is. That's about 45 degrees. Well, it is 45 degrees. So if we were to plot our terminal ray, it would look like that. And now the reference angle, this is in quadrant 1. So whatever the given value is, that is also your reference angle. So from our terminal ray to the closest x-axis, it's pi over 4. Now we can plot pi over 6, looking at our unit circles right here. That's equivalent to 30 degrees. Right about there. We are in quadrant 1, so the reference angle for pi over 6 is pi over 6. All right, whenever we do the third example, remember, it is negative 5 pi over 4. So rather than going in a counterclockwise direction from the positive x-axis, we need to go in a clockwise direction. Now, 5 pi over 4 occurs here in the unit circle. But if we're going to do, a regular rotation, if we were to graph 5 pi over 4, positive 5 pi over 4 from the positive x-axis, we would go this way, which would be 180, let me think, 225, 240, yeah, 240 degree rotation. So from here to here would be a 240 degree rotation. So what we need to do is we need to do a negative 240 degree rotation and go here. So that's what our graph would look like. There would be our, I just graphed it on the wrong one. Sorry, y'all. It should be over here. There we go. So disregard that one. Sorry. Negative 5 pi over 4 would be over here. Now, negative 5 pi over 4. Remember, if we were going in the standard way that we should go, it would be here. But since we flipped it, we're going in the negative direction, it would be there. And now to find the reference angle, we mean the distance from here to here, here to here. Well, if we just go to the reverse side of the y-axis, that's pi over 4 units from here to here, here or here. So therefore our reference angle here is pi over 4. Don't worry about that one for now. Okay, now we're going to graph 5 pi over 3, which looking at our unit circle, here's 5 pi over 3. That is a 300 degree rotation from the positive x-axis. And now we need the reference angle from here to here. So here's 5 pi over 3 in our unit circle. If we were to reflect that over the x-axis, we'd be here. And from here to here is pi over 3. Therefore, our reference angle from here to here is also pi over 3. All right, now if we're about to do 7 pi over 6, here's 7 pi over 6 in our unit circle. If we were to start a rotation from the positive x-axis, that would be a 210 degree rotation. Now to find the reference angle, we need the distance from here to here, or going back to our bigger unit circle from here to here, here to here. Well, from here to here is the same reference angle as from here to here. Therefore, our reference angle is pi over 6. All right, now this cheat sheet looks a little bit familiar. This is what we did day 2, except now they have given you the equivalent, the radian equivalent 2 degrees. So 30 degrees is the exact same thing as pi over 6. 45 degrees, same thing as pi over 4. 60 degrees, same thing as pi over 3. So we're going to use the exact same values that we had here for unit 3, day 2. So sine of theta is still 1/2. This is still root 3 over 2. Root 3 over 3. Root 2 over 2. Root 2 over 2 and 1. And for our 60-degree family or our pi over 3 family, that would be root 3 over 2 for your sine value, 1/2 for your cosine value, and root 3 for your tangent value. And here, if you remember this acronym here, CAST, it tells you which of these values, sine, cosine, or tangent, are positive in the given quadrant. So in quadrant 1, all things are positive, sine, cosine, and tangent. Quadrant 2, only sine is positive. Quadrant 3, only tangent is positive. In quadrant 4, only cosine is positive. All right, now in order to fill out this set of information here, it's going to help to remember what our coordinates were from day 2. You can go back to day 2, look at those notes, or you can fill in the missing information now. What I'm going to do is I would like for you to pause the video and see if you can remember what the coordinates are for these 3 particular radians or degrees, if you'd rather convert them to degrees. All right, so for pi over 6, remember that is a 30-degree rotation from the positive x-axis. It produces a coordinate of root 3 over 2, 1/2, with the tangency of root 3 over 3. Pi over 4 is the same thing as a 45-degree rotation from the positive x-axis, giving you a coordinate of root 2 over 2. A tangency of 1. Pi over 3, that is the same thing as a 60-degree rotation from the positive x-axis, giving you a coordinate of 1/2. Root 3 over 2, and a tangency of root 3. And just a reminder, these are not your x and y and slope values anymore. This is cosine, this is sine, this is tangent. Now, if you remember all of these, it's going to make it a little bit easier to fill in the rest of these particular open spaces. Also, look for patterns here. Notice that if we're not looking at our quadrant angles, these are our quadrant angles here. Let's leave those out for now. Look at the pattern that these fractions follow. 6, 4, 3, 3, 4, 6, 6, 4, 3, 3, 4, 6, right? Also, notice the pattern that your coordinates follow. First of all, they're all over 2. All of them have a denominator of 2. And then if we start on the right side, the sine value, the numerator goes 1, 2, 3. Now over the cosine, 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. See, it's not that bad. If you'd like to fill in the rest of the coordinates, you can. I think it would be good practice, but for the sake of time, I'm going to skip that for now. All right, let's find the sine value. What is sine of pi over 4? Pi over 4, remember, that is in quadrant 1. So you could, if you wanted to, sketch a graph of that. Quadrant 1. In quadrant 1, remember, all values are positive. So now we can go to our little cheat sheet over here. Look at the pi over 4 column. It's going to be one of these 3 answers. We just need to know the sine value. So it'd be root 2 over 2. Cosine of pi over 3. Here's our pi over 3 column here. It wants to know the cosine of that. Pi over 3 is here. Quadrant 1. Where all things are positive. So once again, pi over 3, here's the pi over 3 column. All it wants to know is the cosine value. Positive 1/2. tangent of pi over 6. Here's pi over 6 right there. That would be quadrant 1 where all values are positive. And in case you don't remember, how do you know all values are positive in quadrant 1? Remember, that's what these letters stand for. Quadrant 1, all things are positive. Okay, tangent value of pi over 6. Here's the pi over 6 column right here. Tangent value will be positive root 3 over 3. Now for 2 pi over 3, I'm going to go back to our unit circle here. For 2 pi over 3 from the positive x-axis, here's where it would be right here. Well, that's in quadrant 2. And in quadrant 2, what is the only thing that's positive? Their sine value. So since it is telling us to find the sine value, since we already know it's going to be positive, if you wanted to, you could just go ahead and put positive there so that you would know that you're going to get the right answer. All right, for 2 pi over 3, we need to find sine of 2 pi over 3. Well, here's 2 pi over 3. Now, if I were to reflect where we currently are over the y-axis, we would be here. So 2 pi over 3 is here, reflect it over the y-axis. We are now there. So this gives us the reference angle of pi over 3. I'm just now realizing it doesn't want us to figure that out though. It wants to know what is the sine value. Sine value is root 3 over 2. And remember, we've already determined that it's going to be positive. All right, let's find the sine value of 3 pi over 4. Here's 3 pi over 4. That is in quadrant 2, where the sine is the only thing that is positive. We are finding the sine value, so our answer is going to be positive in this case. All right, here's 3 pi over 4. Let's reflect it over the y-axis. So these are the set of values that we're going to need. We need the sine value, so that's going to be root 2 over 2. Okay, negative pi over 4. They want us to find the tangent value of negative pi over 4. Well, hang on. If it was positive pi over 4, we would just go here, a 45-degree rotation. Well, they want us to go negative pi over 4, so we need to do a negative 45-degree rotation, meaning this is where we are. We are currently in quadrant 4, where the only thing that is positive is your cosine value. Well, since it wants us to find the tangent, we can automatically write down a negative so that we don't get the wrong answer. Okay, 7 pi over 4. If we reflect this over the x-axis, we're at pi over 4. So we can use these values here. It wants us to know the tangent value, or find the tangent value, which would be 1. Okay, cosine 2 pi over 3 is here. That is in quadrant 2. What is the only thing that's positive in quadrant 2? Sine. The only thing that's positive in quadrant 2 is sine. Well, since we're finding cosine, our answer is going to be negative. Okay, let's go back. Where is 2 pi over 3 again? It's here. If we reflect that over the y-axis, we'd be here. So these are the set of values that we're going to use. It wants us to know the cosine value, so that would be 1/2. Please pause the video, try the rest of them, and then restart the video, and then you'll magically see all the answers appear. All right, there are the remaining answers. You might be a little confused on the zeros. Just remember, our quadrant angles have the following coordinates assigned to them. Oh, I forgot to give you your tangency here. So here's cosine, sine, with a tangency of 0. Here we have cosine, sine, with a tangency of undefined. Over here, cosine, -1, sine, 0, tangency, 0. Over here, cosine, 0, sine, -1, tangency, undefined. All right, here on this page, they tell you how to go from either radians to degrees or from degrees to radians, which might help you to know this because maybe you don't want to take the time to memorize the unit circle, which I recommend you do, but I'm a realist. I understand that that can be a bit of a daunting task. But as long as you know the degrees, like here's 30 degrees, right? Here's 180 degrees. Here's 210. Here's 270 degrees. As long as you know the degrees and how to convert from degrees to radians, well, then you really don't need to memorize anything. You're just going to have to do a little math, which hopefully won't be too hard. So for example, if we're going to convert 135 degrees into radians, we're going from degrees to radians. So we would need to do 135 times pi over 180. Now, I'd like to remind you, this is a non-graphing calculator test. So you're going to need to know how to do this without using a calculator. All right, so let's do it. I like to convert whole numbers into fractions whenever I'm multiplying a whole number with a fraction. And now I just multiply numerator times numerator. 135 times pi. 1 times 180 is 180. Now, if you'll notice, both of these numbers are divisible by 5. So I could just keep reducing by 5 as much as possible. Let's see. 5 doesn't go into 1, but it goes into 13 twice, with 3 left over. 5 goes into 35 7 times. Don't forget the pi. 5 does not go into 1, but it goes into 18 3 times, with 3 left over. 5 goes into 36 times. Now that looks a little bit more manageable. If you'll notice, 9 goes into 27. 9 also goes into 36. 9 goes into 27 3 times. 9 goes into 36 4 times. So a rotation of 135 degrees is the exact same thing as 3 pi over 4 in radians. All right, now we're going to convert 7 pi over 10 to degrees. Here's how we do that here. Here's how we do that from radians to degrees. So 7 pi over 10 times 180 over pi. Okay, well, this one won't be a little bit as challenging as the other one. Won't be as challenging as the other one. You're all going to have to forgive me. I'm feeling a little under the weather. I'm hoping that I'll be able to teach you this tomorrow rather than have you play this video. Notice here that we can cross cancel. The pi's cross cancel. 10 goes into 180 18 times. Now we can multiply straight across. 18 times 7. Oops, that should be a 5. I'm sorry. 8 times 7. No, wait, never mind. That's good. Sorry, y'all. Once again, feeling a little under the weather. We get a final answer there of 126 degrees. So 7 pi over 10 is the same thing as 126 degrees. All right, now let's start with example 4. So what if I took away your unit circle here? Or you didn't memorize the unit circle, at least as far as the radians go. And you were asked to draw the following angles in standard position. And they said, hey, draw 3 pi over 4, 3 pi over 4 in standard position. You're like, I don't know what 3 pi over 4 is. Well, as long as you know how to convert from radians to degrees or vice versa, you can hopefully make it a little bit more manageable. 3 pi over 4 times 180 over pi. Try and simplify that. Please pause the video. All right, we can do some cross canceling again. The pi's cross cancel. 4 goes into 180 45 times. 4 goes into itself once. So now we can do 3 times 45, which would be 135 degrees. And here we just have 1 times 1, which is 1. We don't need that though. So now we know how to apply 135 degree rotation from the positive x-axis. Be right about here. I'll let you do the rest. All right, there's the answers for the other two. That last one might be tripping you up just a little bit. 7 pi over 2. If you were to convert that to degrees, that would be a 630-degree rotation. And you may be asking yourself, 630-degree rotation, where do we plot that? Well, that's where we can use our coterminal angles. Let's keep subtracting 360 from this until we get to a number that is between 0 and 360. Well, if you took 630 and subtracted 360, you would get 270 degrees. Now we know where 270 degrees is. So now we can plot this. Now remember, 270 degrees, that's the coterminal. So 270-degree rotation, or that ray at least, is going to be here. A 270-degree rotation would be here. But remember, this was a 630-degree. So we need to go around once and then stop upon our return. Okay, so we just reviewed how to find coterminal angles in degrees. You just add or subtract 360 degrees. But what if they wanted you to find the coterminal in radians? Well, one time around the unit circle is 360 degrees. We all know that. But what is one time around the unit circle in radians? 2 pi. So the way that we find coterminal angles is you either add or subtract 360 degrees if it wants it in degrees, or you add or subtract 2 pi if it wants it in radians. So on the last page of our notes, that is exactly what it wants us to do. It wants us to find coterminal angles in radians. So for pi over 4, we would need to add 2 pi to that, meaning we're going to have to add a fraction with the whole number. Here's one way you can add fractions with whole numbers. Create a denominator underneath your whole number. Now I'm going to do some cross multiplying here. Pi times 1 is pi plus 4 times 2 pi is 8 pi over 4 times 1. And pi plus 8 pi is 9 pi over 4. And now we have our positive coterminal angle. Let's now go find our negative coterminal. So we are given pi over 4. To find the negative coterminal, we're going to subtract 2 pi. And I'm going to put that over 1. Now we're going to start with pi times 1, which is pi, minus 4 times 2 pi, which is 8 pi over 4 times 1. Let's simplify the numerator. Pi minus 8 pi is negative 7 pi over 4. We have now found our negative coterminal angle. Okay, let's find the negative and positive coterminal angles for 11 pi over 6. Let's start with the positive. We need to add 2 pi to that. Cross multiply. 11 pi times 1. Six times 2 pi. I don't know why I put an equal sign there. Sorry, all plus over 6 times 1. Simplify the numerator. 11 plus 12 pi. There's our positive coterminal angle. And now let's go find the negative coterminal. Cross multiply. 11 pi times 1 minus 6 times 2 pi over 6 times 1. Simplify the numerator. 11 pi minus 12 pi is negative pi over 6. That's our negative coterminal. Please pause the video. Try solving the remaining on your own. Once you're finished solving, hit play, and then you're going to see the answers magically appear. I hope you have a fantastic day, and I hope to see you tomorrow.